Okay, so this is the Dijkstra algorithm for the single shortest path using a directed graph. A directed graph means that it has an arrow from one vertex to the next. So what that means is from V0 we could reach V1 in one direction only. We cannot go backwards. We cannot go from V1 to V0 because the arrow is pointed from V0 to V1. This is important because if the graph was undirected, meaning it had no arrow, you could go in either direction, which makes the question a little more complicated. And is a way lecturers could trick students in exam. So we'll do our next video with the undirected graphs. Right? So now to start this question, I have to tell you what is the starting vertex. In this case, the starting vertex is V0. Right? So in doing this question, you want to count how much vertices you have, and we have 6. So that means we want to draw out now 5 tables, or n minus 1 tables, right? So as you can see, I already have all 5 of my tables already drawn out. Right? So now the next step in this question is you have to have what you call a finish column or a finish section, right? So for the first one, we count in V0 as since it's the starting vertex, we're going to use it as the first value in this finish column, right? And they're going to look something like this with very crooked curly brackets, right? Right? So what this signifies is, well, first off, this table has for each column, each vertex in the table besides V0, because V0 is the starting vertex, right? And then we have a distance row and a parent row, right? And we go get into that as we do in the question, right? So V0 inside here, right? What this means is we want to go from V0 to each one of these nodes, right? Directly. Could V0 reach these nodes directly? If it could, we update the value here and we update the parent node. So what I mean by this is, if we look at the graph, we'd see that V0 could reach V1 for the cost of 1, right? So that means V0 reaches V1 directly, right? For the cost of 1. So we come here and we update that. The cost is 1 and the parent of V1 is V0, right? So the next one is V2. Could V0 reach V2 directly? Yes, it could for the cost of 6. So 6 and the parent is V0. Now could V0 reach V3 directly? Right? No, it can't, right? So we put infinity because it can't reach it directly and the parent is nil, right? Same thing for V4. V0 can't reach V4 directly, and the same thing for V5 also, right? The important thing here is to remember when we starting is if it could reach the other node directly. If it can't, then it's infinity and nil, right? So now we come back to our finish column, right? So we have V0 finished. So we want our next value to put inside it, right? To choose this next value is, what we have to do is we have to take the next value here, the smallest value in this row that isn't already inside here, right? So as you can see, V1 has the smallest value that isn't already inside here, right? So what we do is we come here, V0, and we put V1. Again, the reason we do that is because V1 has the smallest value and V1 isn't already inside here, right? So now we want to go from V1 to each one of these, right? So we just copy, because we already have V1 and this V1 is the one we're working on currently, we're just going to put back 1 and V0 from here, from the previous table, right? So we want to go to V2. We want to see if we could reach V2 for lesser cost than what we had in this table, right? And what I mean by that is, if you watch the graph, you could see that we could reach V2 from V0 if we pass through V1 for the cost of 1 plus 3 is 4, which is less than 6, right? Watch it again. So we could reach V2 for the cost of 4 if we pass through V1, right, which is less than 6. So that is how you're going to continue doing each one of these questions. You're going to consider what is the previous value to reach V2 and what will be the new value from this one that we're currently working on, V1, right? So we're going to consider what's the previous cost to reach V2, and we're going to consider the new cost from the current vertex that we are working on, right? So is 6 less than 3 plus 1? No. Is greater than, so we're going to take the new value 4 and we're going to update who is the new parent of V2, right? The new parent of V2 is V1, right? So now we go back to here. We see we want to reach V3 from V1. Could we reach V3 from V1? Yes, we could reach V3 from V1 for the cost of 4 plus 1 is 5, right? Is 5 less than infinity? Yes, it is. So we update it here. And the new parent is V1, right? So I know it's kind of looking confusing, so we will do each question out. So for V4, could we reach V1 from V4? V4 from V1, sorry. Yes, for the cost of 7. Now we get the cost of 7 because we have to go from V0 to V1 and then V1 to V4, right? And that costs 7. Now is 7 less than the previous value to reach V4? Yes, it is. It's less than infinity. So 7 now comes here and V1. Could V1 reach V5 directly? No, V1 cannot reach V5 directly. If you watch it here, V1 could only reach V3, V4 and V2, but it cannot reach V5. So it remains the same. Infinity and nil, right? So remember what we do next is we update with finish column, right? So we have V0, V1, and we choose the smallest value here that isn't already inside here, and the smallest value in this case is V2, right? Cool. So now we want to go from V2 to each one of these values here. Now because we're working on V2, we're just going to copy back V2 from the previous table. So V and V1, right? So now we go back to the table, to the graph, sorry. Could V2 reach V1? V2 cannot reach V1, so we just copy back what we had in the previous table for V1, right? Right, so now we go back up to V2 to reach V3. Could V2 reach V3? V2 could reach V3 for the cost of 2. Sorry, this had to be explained a little better. Right, so we see now to reach V3 previously was cost 5, right? So if we write this here, to reach V3 previously cost 5, right? Now to reach V3 from V2, we have to consider the current cost to reach V2 and the cost from V2 to V3. So the current cost to reach V2 is 4, right? And from V2 it costs 2 more to reach V3, which is 6, right? 4 plus 2 is 6, right? So 6, right? Now is 6 less than 5? No, 5 is less than 6. So what that means is it costs less to reach V3 using V1 than it would cost to reach V3 using V2. And we could watch it here to see. It costs 4 plus 1 is 5 to reach V3 using V1 rather than using V2 to reach V3, which costs 3 plus 1 plus 2, which is 6, right? So V3 remains the same, right? Now V4, right? V2 to V4. The new cost to reach V2 to V4 is 4 plus 2, which is 6. So we could write it here. And the previous cost to reach V4 was 7, right? So 6 is less than 7, so it is now cheaper to reach V4 from V2. So plus 6, and we update here with V2. Now could V2 reach V5? V2 cannot reach V5 directly, so V5 remains the same. Cool. Now again we're going to update with finish column. So we're going to choose the smallest value here that isn't already inside here. In this case is V3. It just so happened that it's going in numerical order. So that's a coincidence, by the way. So V3, we copy back what was in V3 here, and we're going to see if V3 could reach V1. V3 cannot reach V1 because the arrow points this way and not that way. So we update back V1 with what we had in the previous table, which is 1 and V0. We go to see if V3 could reach V2. V3 cannot reach V2 because the arrow pointed in the other direction. So we update back what we had in the previous table for V2. Right? So now we go from V3 to V4. Could V3 reach V4? Yes, V3 could reach V4, right? So what we have to consider now is if the new cost to reach V3 to V4 is less than the previous cost to reach V4, right? So the new cost to reach V4 is 5 plus 2. V3 to V4 is 2 plus this 5 here, which is 7, right? And the previous cost to reach V4 was 6, right? So 6 is less than 7, so this remains the same, right? Because it is cheaper to reach V4 from V2 rather than reaching from V3, right? So now we go to V5. Could V3 reach V5? Yes, V3 could reach V5 for the cost of 5 plus 3, which is 8, right? Alright, and the previous cost to reach V5 was infinity, and 8 is less than infinity, so we update it here, V3, right? So now we come to the final table and we update we finish column V0, V1, V2, V3, and we choose the smallest value here that isn't already inside here, and in this case again is V4. I swear this is just a coincidence that they're going from 0 to 4, right? So we're on V4 now, so we update back the value for V4 here, and we go, could V4 reach V1 directly? No, it can't. So we update back that. Could V4 reach V2 directly? No, it can't. So we put back the previous values from the previous table that we just worked on. Could V4 reach V3? No, V4 can't reach V3 directly. Arrow pointing in the wrong way. So we update back V3 as it was. Right? So now could V4 reach V5? Yes, V4 could reach V5, as you could see here. But can it reach V5 for less than the previous value of V5? Well, we have to see now. So the cost to reach V5 from V4 is 6 plus 4, which is 10, right? So we could write it here. And the previous value to reach V5 was 8. So 10 is greater than 8, so it remains the same, 8 and V3, right? Now this is not the end of the question as yet, but in the next video we will finish the question because I think my memory will run out on the phone.